You know that feeling when you're staring at a geometry problem, you've got a triangle, but it's not a right triangle? Yeah, it's frustrating when your go-to tools just don't work. Well, today, we are going to unlock a super powerful law that can solve for missing sides and angles in any triangle. It's going to make those tricky problems feel way, way simpler. So let's start with what we all know. When you think solving triangles, I'm betting one famous theorem immediately pops into your head. It's awesome, it's elegant, it's powerful. But it's got this one huge limitation that really holds it back. I mean, the Pythagorean theorem is an absolute superstar of math, right? But it only performs on one very specific stage, the right triangle. Which kind of begs the question, what about all the other triangles out there? You know, the ones that aren't so perfectly angled? How do we solve those? And here's the catch. The entire magic of a squared plus b squared equals c squared hinges on having that perfect 90-degree angle. The second that angle changes, even a little bit, the whole formula just falls apart. And that is the exact problem we are here to solve. Okay, so how do we break free from that 90-degree prison? Well, we need a bigger, better rule. We need a universal law that can handle any triangle we throw at it. Now, don't let a new formula intimidate you. The absolute best way to think about this new tool is right here. It's not some weird alien concept. It's basically a generalized Pythagorean theorem. Think of it like an upgrade to a formula you already know and love. And here it is, the law of cosines. Now, just look at it for a second. The first part, c squared equals a squared plus b squared, that's just Pythagoras. The part we're adding on, this minus 2ab cos c, that's the secret sauce. It's like a correction factor that adjusts the formula for any angle, not just 90 degrees. It's such a brilliant little add-on to the old rule. So we have this awesome new law, but a tool is only really useful if you know exactly when to pull it out of the toolbox. And it turns out the law of cosines is the perfect solution for two very specific situations. So let's get down to it. When do you look at a problem and say, aha, this is a job for the law of cosines? It all boils down to two key setups. The first one is called side angle side, or SAS. This is when you know two sides of a triangle and the angle that's sandwiched right between them. The second is side side side, or SSS. That one's easy. It's when you know the lengths of all three sides. If your problem looks like one of these two, the law of cosines is your absolute best friend. All right, let's put this thing into action. We'll start with that first scenario, finding a missing side when you've got a side angle side situation. Okay, so picture this. We've got a triangle. We know one side is 10, another is 12, and the angle locked between them is 47 degrees. Our mission, should we choose to accept it, is to find the length of that third mystery side. Let's do it. And you know what? It's really just three simple steps. First, we just label what we know. Let's say A is 10, B is 12, and our angle C is 47 degrees. Second, we just plug those numbers right into the formula we just saw. So we get c squared equals 10 squared plus 12 squared minus 2, 10 times 12, cos of 47 degrees. And third, we just punch that into the calculator. And boom, there it is. The missing side, C, is about 8.98. It's really that straightforward. We just found a side that would have been impossible to get with Pythagoras alone. Okay, on to our second main event, finding a missing angle. This is what we do for a side-side-side problem, when we've got all the sides, but we need to figure out an angle. So for this, let's grab an example from our source. We have a triangle with sides that measure 11, 12, and 13. And we want to find the angle that's sitting right across from the side with length 11. This is a perfect job for the law of cosines. Now, this one needs just a tiny bit of algebra, but don't worry, it's nothing crazy. First, we just shuffle the formula around to solve for cos of C. Then we plug in our side lengths. The key here is to make sure that the side we call C is the one opposite the angle we're looking for. So in this case, 11. Finally, to get from that cosine value to the actual angle in degrees, we use the inverse cosine button on our calculator. It usually looks like cos inverse. And voila! The missing angle is about 48.4 degrees. Just like that, we figured out a specific angle inside a non-right triangle. Again, something totally impossible with just the Pythagorean theorem. So let's just step back for a second and appreciate what we've just done here. We've added a genuinely universal tool to our math toolkit, one that can take on any triangle no matter what its angles look like. So what's the bottom line? Let's recap. First, think of the law of cosines as a supercharged Pythagorean theorem. It's Pythagoras, but with superpowers. Second, its two big moments to shine are side angle side and side 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 problems. And finally, with this tool in your back pocket, no triangle is really unsolvable. You've got the key now. And this leaves us with a really cool final thought. We just saw how a super famous rule, the Pythagorean theorem, is actually just one special case of a much bigger, more powerful idea. It really makes you wonder, doesn't it? What other simple rules that we all take for granted are also just a tiny piece of a much grander puzzle, just waiting to be discovered?